Hello class. Today we are looking at side, and side angle side similarity. Alright. Now, I know you're looking at this thing side, side angle side. That didn't show similarity. That shows congruence. We had a whole bunch of stuff we did with side, and side angle side congruence, not similarity. What's going on here? Well, the theorems are a little bit different. That's what's going on. Not looking at the exact same thing. Side similarity, what this says is that if the corresponding side lengths of two triangles are proportional, then the triangles are similar. Alright, so it's kind of like what we saw in the last video. We were saying that if the angles of a triangle are congruent to the angles of another triangle, then we have similar triangles. Here we're saying if the sides are proportional, then the triangles are similar. Okay. And this works for triangles. It does not work for quadrilaterals or pentagons or anything else. It only works for triangles. All right. So if we know that AB to SR is the same ratio as AC to RT, and that's the same ratio as ST to BC, then the triangles are going to be similar. We don't have to go checking to making sure all of the angles are congruent. If the sides are similar, then the angles are going to automatically be congruent, giving us similar figures. All right? And so then we can go into using proportions or scale factor or whatever to figure out whatever it is we're missing, whatever we need to know. Okay, the next one, side angle side, SAS similarity, what this one says is that if an angle of one triangle is congruent to an angle of another triangle, and the lengths of the sides that include that angle are proportional, then the triangles are similar. So this is a kind of a blend between the angle similarity and the side similarity. Here, I know these two sides are proportional. I have no clue about the bottom side. I know that this one angle is congruent to that one angle, but I don't have any idea about the other two angles. I can still conclude that the triangles are similar. And so that's what this is. This is, I know two sides are proportional, and I know the angle in between those two sides are congruent, then the triangles are going to be similar. This does not work if I knew this angle down here. If I knew these two sides here, if I knew XZ and XY were proportional to MP and MN, but then I got this angle down here that was not in between them. This is side angle, which doesn't work. It didn't work for congruence. It doesn't work for similarity. Okay, it has to be side angle side, or it has to be side. Okay, or angle, which did not work for congruence, but does work for similarity. All right, and here are the three that we have, and that kind of came out a little small, so I'm going to zoom in just a little bit. And there it is. All right. So here is a summary of the three triangle similarity theorems. Okay, there's angle, which, as we've said, if you know two angles, then you know the third one. So this is really angle. But we can just forget about the third one because it's a given. We don't need it. All right. So we have angle. So if you know two angles of one triangle congruent to two angles of another triangle, they're similar. We can use proportions to figure out missing side lengths and things like that. This did not work for congruence, but it does work for similarity. And then there's side, which is a lot like the congruence theorem, but this one is saying that instead of the sides being congruent, here the sides are going to be proportional. So they have the same ratio. This equals that. Then they're going to be similar, and so the angles are automatically going to be congruent. And side angle side similarity. And you have two sides proportional to two other sides. The angles in between those two sides are congruent. Side angle side, not side angle. All right, side angle still is no good. All right, so let's open this up, zoom back out, and we will take a look at some examples. All right, here we go. So in exercise 1 and 2, we need to determine whether triangle RST is similar to triangle ABC. Okay, so in number 1, here we have triangle RST, Number 2 is still RST, but in both cases we're looking, is this similar to triangle ABC? Now it gives us no clue about the angles, so we don't know if the angles are congruent, but we know if all 3 sets of sides are proportional, then we've got similar triangles. So let's take a look at this. So first, we look at our similarity here, and RS goes with AB. So that would be RS and AB. It doesn't tell us which one is old, which one's new. Doesn't matter. We'll just put RS on top and AB on the bottom. Why not? So RS is 9 over AB, which is 6. And we're going to simplify this down. 9 over 6 would be 3 over 2. So this is 3 halves. Okay, so if this is actually going to work, if these are similar, the other sides have to match up and have to give us 3 halves for our scale factor. So let's try the next one. 7.5, right, because ST goes with BC. So ST is 7.5, BC is 5. Alright. I don't know that one, and someone throw my calculator. There it is. Alright. So I'm going to plug this into the calculator just because I feel like it. 7.5 divided by 5 is 1.5, which is 3 halves, right? So there it is. 3 halves. So far, so good. Let's just check that last one. TR and CA. So TR is 4. CA is 2.5. And see what we get here. 4 over 2.5 is 1.6. 1.6, which is not the same as 3 halves. Not 1.5, is it? And so these are not similar. Not similar. Because 3 halves does not equal 1.6. No good. Okay, let's try number 2. Maybe number 2 will work out for us. Let's see. First, we need RS goes with BC. So which one's RS? RS is right here. That is 12 over 5. 12 over 5. And that's going to go, so 12 fifths over AB. AB is 6. That's a lovely little fraction. So again, I'm going to pull out my calculator because I can. So we have 12 fifths divided by 6. 0.4. 0.4. Okay, let's see what's next. We have let's see, we'll go with ST because that's next here. We have ST goes with BC. So ST is 2, BC is 5, which y'all should remember your fractions to decimals. 2 over 5, 2 fifths is 0.4. Again, so far so good. Let's see if the last one works. So the last one would be RT to AC. So RT is 1, AC is 2.5. So let's see what that gives us. 1 divided by 2.5 is 0.4. All right. So 0.4 equals 0.4 equals 0.4. So I'm going to write it like this. This is just a way that they like us to write it. It's a little ratio thing. So we're going to say that RS over AB equals, what was next? ST over BC, and that equals RT over AC. And since that all works, this is similar. Number 2 is going to be similar. All right. So there it is. All 3 sides have to match up. Having 2 sides proportional, that's nice, but it isn't going to cut it. You got to have all 3. It's no good. Okay, let's take a look at number 3. Find the value of x and y that makes triangle RST similar to triangle HGK. Okay, so on here we need x and y. Let's see, on HGK, they've given us some angles and we have information about all 3 sides. RST, we just have 2 sides and an angle. So, if we don't know what that is, because we don't know that these triangles are similar, we want to make them similar, but we don't know what that is. And so that means we cannot use side, 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 because I don't have all 3 sides of RST, do I? So we can't use that. We can't use angle, 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 because I've only got 1 angle here, and I've got 2 angles there. If I had another angle there, I could do something, but I don't have that. So what I have left is side, angle, side. Side, angle, side. I need 2 sides. I've got 2 sides. And I need the angle that is in between those 2 sides, which would be those 2 angles. So we're going to do that. And I'm going to do the angles first, because if you remember, the angles have to be congruent, which makes them really easy to solve for. This has to equal that, so that my angles will be congruent. So I have 2y plus 16 equals 3y minus 4. That's a y, not an x. Y. There we go. All right. So let's just work this out. I'm going to subtract 2y from both sides. 16 equals y minus 4. Add the 4 to both sides. And y equals 20. Easy enough. There it is. Not too bad. All right, now let's take a look at x. Well, x, I need the ratios to be the same, right? So let's see, let's set up my ratio. I have RS, which goes with HG. So 3 to x plus 7. X plus 7. And that needs to equal the only other side I have over here, which is RT. So RT is going to go with HK, which is this one here. I had RS on top, so RT has to go on top. So that gives me 3 minus x over 8. I don't know what my scale factor is, because I don't know what don't know what this side is. I don't know what that side is. So I don't know my scale factor. So I have to set this up as proportions, which means we're going to do cross products, little butterfly method thing, right? And this is going to be not a whole lot of fun, I'll admit, because I'm going to have x's here and have x's there. So what I end up with is 3 minus x times x plus 7 equals 3 times 8. 3 times 8. Well, that side's easy enough. That's 24, right? But over here, we're going to FOIL, or double distribution, or whatever it is you call it, box method. I don't care what it is. We're going to FOIL this all together. So let's see here. We have 3 times x is 3x. Negative x times, 3 times 7 is going to be 21. I was getting ahead of myself a minute ago. Negative x times x is negative x squared, and negative x times 7 is negative 7x. Of course, we're going to combine like terms, and it does help if we put it in like standard format. That'll help us out a bit too. So let's see. I'm going to take my x squares first. I've got negative x squared, and then I'll take my x's. I've got 3x minus 7x is going to be negative 4x. And then my plus 21. Plus 21 equals 24. So this one's going to be a bit more complicated because we have this x squared here. And I'm going to use factoring here, but I'll admit it's easier if my x squared is not negative. So I'm going to get rid of that negative in front of my x squared. And to do that, I'm going to multiply the entire thing times negative 1. All of it. And all that's going to do is change my signs. So I have x squared plus 4x minus 21 equals negative 24. And of course, we have to set this equal to 0 because it's a quadratic, and that is the easiest way to solve quadratic equations. So we are going to add 24 to both sides. And I am running out of room, so I'm going to come up here. And that gives me x squared plus 4x plus 3 equals 0. And now I can factor this. Alright, so I'm going to put my parentheses here, equals 0. I have x squared at the beginning, so I'm going to have x times x. And now to remember this back number, these are numbers that multiply to equal 3, add to get 4. Well, there's only one thing you can multiply to get 3, and that is 3 times 1, which, luckily enough, do add up to equal 4. So plus 3 plus 1. So there's my factors. We set each one of those equal to 0. X plus 3 equals 0. X plus 1 equals 0. Which means x over here, subtract 3 from both sides, x equals negative 3, or x equals negative 1. Could be either one, we don't know. Now, for this to work, since we had the square roots and we've got two answers, we do need to check and see, do they both work? Can I plug these in for x and have this work? So what I'm going to do is I'm going to do this twice. I'm going to take negative 3 and I'm going to plug it into my original proportion, see if this works. So we're going to check it. So I have taken my original proportion, this right here. 3 over negative 3 plus 7 equals 3 minus negative 3, so that's going to be actually 3 plus 3 over 8. So that negative 3 plus 7, that's going to be 4. So I've got 3 over 4 equals 3 plus 3, because it's minus a negative, 6 over 8. And does 3/4 equal 6/8? Well, yeah, divide by 2, divide by 2, got that. So this one checks out. This one's good. We can use x minus 3, it's good. Now let's try the negative 1. We're just going to plug it straight into the proportion again. So we have 3 over negative 1 plus 7 equals 3 minus negative 1 over 8. Negative 1 plus 7 is 6, so this is 3 over 6. 3 over 6, which equals, let's see, 3 minus a negative, so 3 plus 1, so that would be 4 over 8. Does 3 over 6 equal 4 over 8? Well, 3/6, that's 1/2. 4/8 is also 1/2, so this one also checks out. That one's good. So this works as well. So our answer, y does have to be 20. That's the only thing we get for y. But x could be either x equals negative 3 or x equals negative 1. Either one of those will work for the x. All right. So that one was a little bit more complicated, but I didn't want to give you one that was a little bit more difficult. Didn't want to give you just a bunch of easy examples, and then you have something really difficult like this on the homework. It's like, no. So there we go. I want to give you at least one hard one, so you can see that. All right. Let's get some easy ones again. Oops, zoom out just a bit so everything fits. And everything's blurry. There we go, that's better. A little bit. Not much. Okay, we want to verify that triangle RST is similar to triangle XYZ. And then we want to find the scale factor of RST to XYZ. So we have triangle RST, we have triangle XYZ, we have the lengths of their sides. We don't have the triangles drawn out. That's okay, we don't need them. All we need is the lengths of the sides, right? So here we go. We've got our proportions. There they are. We have 12 over 28, which should equal 15 over 35, which should equal 24 over 56. Right? Because RS goes with XY, ST goes with YZ, RT goes with XZ. So we do have those right. Okay. So let's just simplify all these. Okay, 12 and 28 are both divisible by 4, so that would give us 3 over 7. 15 and 35 are both divisible by 5, and so 15 divided by 5 is 3, 35 divided by 3 is 7, there we go, so I can talk. And these are both divisible by 8, so that would be 3 over 7. Hey, there it is. So it works. All of our ratios come out good. It works. We have verified it. This checks out. Now we need a scale factor from RST to XYZ. Remember scale factor? Scale factor is new over old. So the new one is the one that comes last, right? This one's older by like half a second or something. Anyways, so this is the new. This is the old. And that is not how I worked this out, is it? I had RST on top. So I have it backwards. So all I really have to do, I just have to take it and flip it over. So my scale factor is going to be 7 over 3. Like that. Right? So that was easy enough. Okay, let's take a look at 5 and 6. Let's see here. The shortest side of triangle similar to triangle ABC is 15 units long. We want to find the side lengths of the other sides. Okay. So I know one side is 15, and not only do I just know it's 15, I know that this is the shortest side of the triangle. I know the triangle is similar to triangle ABC. They just really want to talk to me, but I don't care. All right. So that means it is going to be proportional. All the sides are going to be proportional. So if this one's 15, it is going to correspond with the shortest side of this triangle. So to set this up, I'm going to go from this to that. So this is my old, that's my new. My 15 units is my new. Short side is 6. So new, 15, over old, 6. And 15/6, let's see, that was about divisible by 3, so this is 5/2, or 2.5. Okay, so there's my scale factor. Now all I have to do is multiply by my scale factor. This is my K, scale factor. So my other one, I'm going to have 7 times 2.5, which is what? 7 times 2.5. 17.5, and 9 times 2.5, which is 22.5. And those are my other side lengths. Let's take a look at them. Now I have the longest side of a triangle similar to triangle ABC, and that's 6 units. So this is the longest side. My triangles are similar, and we have 6 units long. We need the other side lengths. So we're going to do the same thing. First, we need to come up with the scale factor. Well, my new one is 6 units long. My old one, what do I start with? Let's see. This is the longest side, so that's going to be the 9. And so that is 2/3. I'm not going to write that one as decimal, because it goes on forever. It's 0.66666666666 on and on and on and on and on it goes. So let's see here. We set up our other sides. So the other sides, I use the 9. So let's go with 7 times 2/3, which is, it's going to be 14/3. I don't really need to calculate for that. 14/3, which is 12 and, sorry, not 12. That's 4 and 2/3. And the other one, we had, let's see, we got the 9, we got the 7, we need the 6. 6 times 2/3, which is 12/3, right? Yep, 12/3, or just 4. So one is going to be 4 and 2/3 units long, and the other one is going to be 4 units long. And there we go. So remember, When you are solving these, you can either use scale factor, like I did here. You can use proportions, like we did. Where did we do our proportions? We did our proportions here, cross products, right? The lovely butterfly method. It's a messed up looking butterfly, but there it is. Right? We use cross products. All three pairs of sides have to be similar, like we had here. If they are not similar, if they do not all come out to the same ratio, not going to work. It is not similar. But if they do, all three come out to the same ratio, it's similar. And so we'll know the angles will match up. Or we can have side angle side. The side, an angle, and the side. The two sides are similar. They are proportional, have the same scale factor, and the angle in between those two sides are congruent. And then, of course, there was angle, we talked about the other day. All right. So, hopefully you found that useful, and I'll see you next time.